Alright guys, so today I am going to go over an extra practice problem to help you guys feel prepared for your test tomorrow, and then I'm going to go over some of the cooldowns, alright, which were in that packet that I gave you as a review. Okay, so this is something I just want to go over to help you feel good about the test tomorrow. So, right here, as you can see, we have some missing values, and it wants us to find what those missing values are. Well, we can use our formula, which is your y's minus your y's and your x's minus your x's, because we have 2 points on a line not going through the origin, and set that equal to our slope. And they gave us what our slope is, alright? So now we can fill this information in. I'm going to label my x and y coordinates so then I can plug them in. So I'm going to start off with 8 for y, and then I'm going to pick my other y value, which is b. Then my x value, I need to start up here again because that's what I did for the first one. And then I need to plug my other x value in. And then I know this is going to set equal to 2, so I can make that 2 over 1 to make it all even, alright? So I need to find a number that I could plug in here to get 2, and a number I could plug in here to get 1. Well, what I could do there is, what is something minus 4 that would give me 1? Well, what I could do is I could add these two together to find that number. So if I take 4 plus 1, I get 5. So let's stick with 5 for now. Alright, now let's look up here. 8 minus something gives me 2. Well, I could plug in 2 here to figure out what my number would be. So 8 minus 2 gives me 6. Alright, so I'm going to plug in 6 and 5 there, alright? So 8 minus 6 equals 2, and 5 minus 4 equals 1. Now, is that a true statement? Yes. So, my A value is 6, and my B value is 5. So that is how you would do a problem there with missing variables, alright? Okay. Now what we're going to do is go over the cooldowns. Okay. So here we go. What is a dilation? Alright, so there's a lot of information you could put in here, okay? So, what a dilation does is it makes figures, line segments, or figures larger or smaller. So it doesn't always make them bigger, and it doesn't always make them smaller. It could do either. Okay? Some also important information is the angles are congruent to original. So congruent is, once again, a fancy word for same. Alright? It also creates similar shapes. So if we dilated a triangle, that dilation would then be a similar shape. It would not be congruent, because congruent means the same. So if we're making it bigger or smaller, it cannot be congruent. Alright, so there's that. Okay, now let's do this next one. Okay, so it says using A, okay, we're going to dilate A, which is right here. We're going to use P as the center of dilation, and our scale factor is 3. So we're going to take original times scale factor to get new. So we're going to start at our center. My original distance from P to A is 1. Well, it gives me my scale factor, which is 3. So that means my new distance would be 3. So we're going to start at our center again and go 1, 2, 3. And that is where A prime would be. Alright, now we're going to dilate B using P as the center, but our scale factor is 2 now. So I'm going to take my original distance from the center, which is 1, 2 times my scale factor, and I would get 4. Oops, there you go. So I'm going to start at my center again and go 1, 2, 3, 4. And that is where my B prime is. Okay, now here we go. It says Lynn drew a triangle and a dilation with a scale factor of 1/2. So that means we're getting smaller. Okay? What is the center of dilation, and explain how you know? Well, I need to pick a point that would go through, that I could draw a line through all the rest of the points. So, I can't really draw a line here because that's not going to help me. And same with this point. If I started here, that wasn't going to work. So if I look right here at A, if I draw 2 rays, both of those points then get crossed through. Alright? Okay, so the rays go through the points. So our center is A. Alright, it says which triangle is the original? Well, as we can see here, these are the triangles we're working with. Now, they don't have any prime, so we can't look at that. So we're going to have to look at the scale factor. So since the scale factor is 1/2, that means our shape's getting smaller. So that means we must go from ABC to ADE, because that would be smaller. So ABC is original. The scale factor is 1/2, so the triangle gets smaller. Alright, so that's how we know. So we went from the big one to the small one, and that's how we know because our scale factor is 1/2. Alright, now here we go. Draw an image of rectangle ABCD under a dilation using P as the center and a scale factor of 1/2. So once again, our scale factor is less than 1, so this is going to get smaller. So I'm going to find my original distances from each point, so 2 and 4, multiply those by 1/2, and so now I'm going to go up 1 and to the right 2. Alright, now I'm going to continue that pattern. 4 by 2, well, I already know half those distances is 1 and 2. Alright, now since this is a rectangle and this dot's in the very center, we can just plot those same points on the other side. You can count all that to double check, but if you notice that pattern, you can just go ahead and plot those points. So there's that. Okay, so we need to create a dilation. So it says it goes, here's the center, so that's the center, we can call that P, okay? And then we need to describe this dilation. It goes from the smaller triangle to the bigger triangle, so that means our scale factor is going to be greater than 1, alright? So we're going to start here and find our original distances so we can then know what our scale factor is. So that would be 1. And then it ends up going to 1, 2, 3. So our original times our scale factor equals our new. What times 1 equals 3? It's 3. So our scale factor is 3. Our center is P, and I can just list the points there. So that would be 3, 0. And then we would dilate corresponding points. If you want, you can label these and say dilate points A, B, C. It does not matter what you put there, as long as you have a scale factor, a center, and then describe what you're dilating. Alright, so right here someone gives us some transformations to show going from this shape to this shape. Let's see if they're true. So dilate using center D and a scale factor of 2. So let's find my original distances and then our new. Okay, so my original is 1 and my new is 2. So 1 times 2 does equal 2. Now let's go over here. 2 by 1, and then it's 4 by 2. Once again, 2 times 2 equals 4, 1 times 2 equals 2, so we're still good. 3 by 1, so our next one should be 6 by 2. 6 by 2. Okay, so that is correct. Now it says reflect using line AE. Well, if we did that, these shapes would then be reflected this way, or this one would be reflected that way. Is that what happens? Nope. So this method is not correct. Now how we could fix it is if we drew this line here and call that line L and say reflect over that line, because if we reflect over that line, then it would land on top. Alright, so as long as you have that it did not work because it flips the wrong way, then you're good. Alright, how do we know that these are similar? Okay, well, what we need to do is look at their angle and side lengths. Okay, so if I look here, 25, 25, 125, 125, 55, 55, 55, 55. Angles are congruent. So that is one way we know. Now, we could start and say that this is our original figure and this is our new. So we could see 4.5 times something equals 6. So you might want to get your calculator out. And if we do that, and you plug that into your calculator, you'd get 4 over 3 could be your scale factor. Now if you went from 6 to 4.5, you then would have a scale factor of 3 over 4. So it just depends on which way you go, but you should be able to have 2 different side lengths and be able to find your scale factor there. Okay? Alright. Okay, so on this one, show the triangles are similar. So on this, you could use patty paper, and you could put the patty paper, and if you put it on each angle, you would see that the angles are congruent. So, angles are congruent. Alright, and then what is the scale factor? So we're going from 3 units to then 4. So I'm going to take 4 and divide that by 3, and I get 1.33333. Alright. So that means, sorry, I kind of wrote this wrong. I forgot to put the scale factor there. So 1.333 is the same as saying 4 over 3. So our scale factor could be 1 1/3, or 4 over 3, or 1.33 repeating. Any of those would work there. Okay, so these triangles are similar. Let's find the value of AB. Alright, so we know that if we have 2 things, so we need to have our slope, okay? Because if we know our slope, then we can set these equal to that. So our slope is vertical over horizontal. So I'm going to use the vertical and horizontal distance that they have given me. So 2.1 over 1.4. Now, if I reduce this so I can plug that into my calculator, I get 1.5. Alright, so now let's write that in fraction form. So 3 over 2 is equivalent to 1/2. So that means we could plug in 3 for A, because that's my vertical distance, and 2 for my horizontal. Alright, now we're going to find the slope of these lines. So I'm going to find a point that I could find the coordinates to if I wanted. And then I need to find another point, so then I can find my vertical over horizontal distances. So this would be 2, and this would be 1. So, line K has a slope of 2. Now if I look over here, I'm going to find 2 points that I know I can find the coordinates of. And if I find those distances, I have 1 over 1, which just equals 1. So line L has a slope of 1. Now it says we're going to graph a line that has a slope of 1/3. So our slope is vertical over horizontal. So I'm going to set that equal to 1/3. So this means my vertical distance is 1, and my horizontal is 3. So I can start here. You can pick anywhere on here, and my vertical distance is 1, and my horizontal is 3. So that would be my line. So it's always vertical over horizontal. Okay, 11 refers to this on the back here, okay? So make sure you look at that as I go over these answers. So the slope is 2 over 6. Alright, so if I find some points on this line, so let's say we use 5, 6, and then let's use this point here, which would be 11, 9. So that is what I'm going to be using, so bear with me. We're going to use 5, 7, and 11, 9. Well, if we plug these into our formula, we can then prove that this is our slope. So y minus y over x minus x equals 2 over 6. So let's plug these in, which are 2 points off of our line, and see if we get the right answer. So I'm going to take 9 minus 7, and then 11 minus 5. There we go. So we took 2 points off the line, and there we go. So now it says label the horizontal and vertical side lengths. This is like what we did in lesson 11. So I'm going to take my y value and subtract my other y to find my expression for this line. And then same thing for x minus 5. Took both my x values there. Alright. And then it says explain why this is true. Well, it represents 2 points on the line and the slope. So it has all the information we need. So that's why it is true. Okay, now is this point on the line? Let's figure that out. Well, first we need to figure out our slope. So I'm going to pick this point, and I'm going to label the coordinates 2, 4. And then I'm going to use this point here, which is 4, 5. So I'm going to plug these into my formula and find my slope. So my slope is vertical over horizontal. My vertical is 1, my horizontal is 2. So y minus y over x minus x equals slope. So y, 5, minus my other y, 4, equals my slope. Let's just double check. X minus x Alright, so now what I can do is plug this point in and use one of these points to then plug into this formula. So let's have 13 minus, we're going to use this point, 5 over 20 minus 4. So if I do that, I get 8 on top, and then I get 16 on the bottom, which reduces to 1/2. So yes.
Email